Imagine a future where machines don't just serve us, they anticipate us. Where humanoid robots walk among us with expressions, instincts, and the ability to learn faster than we can teach. A world where artificial intelligence doesn't just react, but decides. That future? It's no longer a concept. It's arriving faster than anyone expected. Welcome back, guys. Alfie here with all the latest AI robot developments of the week. We're diving into this week's biggest AI and robotics breakthroughs, and I'm telling you now, we are not ready for what's coming. From robots showing human-level skills to AI systems pushing the boundaries of what was once considered impossible. These updates will blow your mind. You're watching the AI Nexus, and this is your weekly reality check on the fast-approaching future. Let's jump in, because the machines are moving and the world will never be the same. In a powerful display of innovation meeting academia, Xpang Iron, the company's advanced humanoid robot, recently made a high-profile visit to Tsinghua University in Beijing. This event marked a significant milestone in Xpang's mission to bridge cutting-edge robotics with real-world applications and research collaboration. During the visit, Xpang Iron captivated students and faculty alike with a live demonstration of its capabilities, showcasing fluid movements, dexterous hand control, and real-time environmental awareness powered by Xpang's AI algorithms. As one of the few automotive companies branching aggressively into humanoid robotics, Xpang's presence at one of China's most prestigious engineering institutions signals its intention to be more than just a car maker. It aims to be a key player in the future of intelligent mobility and embodied AI. Taiwanese company Foxconn has revolutionized medical robotics by introducing a new generation of medical assistants named Neurobot. This innovative robot, developed in collaboration with NVIDIA, is designed to optimize the work of medical staff and improve the quality of patient care. Neurobot is an autonomous medical robot equipped with artificial intelligence, capable of performing various tasks in a hospital environment. It patrols corridors, delivers medications and samples, monitors patients' vital signs, and provides information to visitors. The robot is equipped with a screen displaying a constant smile, making it more friendly to both patients and staff. Currently, Neurobot is undergoing trials in several hospitals in Taiwan, including Taichung Veterans General Hospital and Cardinal Tian Hospital. In the future, the robot's functionality is expected to expand, adding support for multiple languages, facial recognition, and assistance with patient mobility. A humanoid robotics startup co-founded in 2018 by futurist Ray Kurzweil and physicist entrepreneur Harry Kloor is in advanced talks to raise $100 million in Series B funding, led by Gauntlet Ventures. The round would reportedly push the company's valuation to $500 million. Signaling strong investor confidence in its long-term vision. The startup first turned heads in 2021 with the unveiling of Beomni, its humanoid robot prototype. Unlike many robotics firms that focus on isolated hardware performance or narrow AI tasks, Beyond Imagination is taking a systems-level approach. At the heart of its platform is a manufacturing operating system designed for human-robot collaboration, aiming to merge teleoperation, autonomous learning, and real-time adaptability in industrial environments. This broader strategy makes Beyond Imagination more than just another humanoid robot company. It's positioning itself as a software-driven robotics platform, integrating intelligent machines into dynamic workspaces where flexibility, safety, and communication with human workers are crucial. Co-founder Harry Kloor stirred debate in 2023 when he stated that robots from companies like Boston Dynamics, Tesla, Figure, and Sanctuary AI would be hiding in the lab for many, many years. The remark reflected Beyond Imagination's bold confidence in its real-world deployment strategy and faster path to commercialization. If this Series B round closes as expected, Beyond Imagination will have the momentum and the capital to accelerate development, expand pilot programs, and challenge the biggest names in the humanoid robotics race. As the industry shifts from spectacle to utility, Beyond Imagination is betting that software-first humanoids will lead the way into factories, warehouses, and beyond. The Japanese have unveiled one of the most advanced next-generation surgical robots named Hugo, developed by Medtronic Company. Hugo is a flexible, high-tech assistant designed for minimally invasive surgery, combining cutting-edge advancements in robotics, ergonomics, and digital visualization. One of Hugo's key features is its 4 independent robotic arms, which can be positioned individually depending on the patient's anatomy and the requirements of the operation. The system also offers intuitive controls that resemble traditional laparoscopic instruments. Gun-shaped joysticks are used, making the transition from conventional laparoscopy to robotic surgery smoother. In addition, Hugo can scale the surgeon's hand movements, transforming large motions into ultra-precise micro-movements of the instruments. This helps minimize errors and reduces strain on the patient. China just staged the world's first humanoid robot boxing match and, for anyone who tuned in to the CMG World Robot Competition's brand new Make a Fighting series, it felt like watching the birth of an entirely new sport. The broadcast shot straight from Hangzhou to living rooms and smartphones everywhere, letting millions witness 4 gleaming Unitree G1 humanoids square up in a rule of 3 elimination bracket that ran as smoothly as any human bout. Only with servo motors buzzing where a crowd might expect adrenaline. Each team piloted its 35-kilogram fighter from a console just outside the ring. But what made the spectacle electric wasn't remote control alone. It was how much intelligence had already migrated into the machines. The G1s kept their knees loaded like seasoned kickboxers, shifted weight with fluid hip rolls, and snapped off crisp straight punches as if coached by human pros. When a bot ate a countershot and toppled, it didn't lie there awaiting a technician. It tucked, rolled, planted its metallic palms, and executed a textbook recovery before the 8-second knockout window expired. That single maneuver drew a collective gasp from the chat scrollers lighting up the livestream ticker. Real steel got back on its feet the way flesh and blood fighters do. The bracket itself was simple. 2 semifinals feeding a final. But the action felt anything but routine. Chinese technology companies are making another breakthrough in robotics by developing a new generation of medical robotic humanoids. These high-tech machines, equipped with advanced artificial intelligence systems, are designed for diagnostics, treatment, and patient care. The new medical robots can conduct initial examinations, analyze symptoms, diagnose based on vast databases, and even perform surgical operations with high precision. Built-in machine learning algorithms will allow them to improve over time, increasing the accuracy and speed of decision-making. Developers are confident that such robots will not only reduce the workload on medical staff, but also help address the shortage of doctors, especially in remote regions. In the future, they may completely replace humans in routine medical tasks, allowing doctors to focus on complex clinical cases. China is already testing the first robot doctors in hospitals and medical centers. If the trials are successful, in the coming years, humanoid medical assistants could become an integral part of the healthcare system, providing patients with round-the-clock care without fatigue or errors. Recently, Tesla's AI and robotics team announced a breakthrough that fundamentally changes how Optimus is trained. Instead of just learning from direct human control or teleoperation, Optimus can now learn from videos. And not just any videos. These are everyday internet videos of people doing regular tasks: cooking, cleaning, folding clothes, moving boxes. Things you and I might watch on YouTube without giving it much thought. This marks a turning point. Tesla has found a way to transfer what a robot sees in those videos, usually filmed from a third-person perspective, into something Optimus can replicate from a first-person point of view. That's a complex leap, because third-person footage doesn't show what the person doing the task is actually seeing. But Tesla's new AI framework is learning to bridge that gap. Right now, Optimus is learning primarily from first-person data. But this breakthrough means that soon, it could start learning from virtually any video on the internet. That opens the door to learning thousands of new tasks without the need for slow, manual data collection. It's a major acceleration in development speed and scalability. Meet Dr. Alfred, a rather unusual surgeon. At first glance, nothing seems out of the ordinary. A green blouse, a stethoscope around his neck, and a fondness for making jokes about the Swiss. He can even recommend the best shawarma in town. But Alfred is not just any doctor. He is a next-generation hyper-realistic robot introduced by the company Engineering Arts. Thanks to an advanced artificial intelligence system and voice recognition technology, the robot can communicate freely. Alfred can answer any question posed to him, including those about his personal life. He also understands almost all the world's languages and, importantly, different accents. According to the company's engineers, robots like Alfred have long-term potential to replace humans in fields such as tourism, making them ideal candidates for roles like hotel receptionists. The engineers joke that so far, Doctor, Alfred has not yet performed a single surgery. Figure AI is not just experimenting, they're deploying, and the results are jaw-dropping. Over at BMW's manufacturing plant, something historic just happened. A humanoid robot, Figure 02, completed back-to-back 20-hour shifts on the X3 production line. No gimmicks, no staged demo, just a humanoid robot doing real work for real hours in a real-world factory. That moment marked a world first. Before this, Figure 02 had already been doing 10-hour shifts for several weeks. That alone was impressive. But to go double that in a single run? That's not just an engineering feat, that's a signal to the entire industrial world that humanoid robots are ready to join the workforce. This isn't a lab test or a simulation. This is Figure 02 working side by side with human employees, performing critical tasks on an automotive production line. It's navigating the same challenges that human workers face: unexpected changes, variations in components, shifting conditions, and still delivering consistent performance across hours of labor. That's what makes this so different from traditional factory robots. Moxy is one of the most advanced humanoid medical assistants in the world, created by the American company Diligent Robotics. It was developed by engineers Andrea Tomas and Vivian Chu, experts in robotics and artificial intelligence. But Moxy is not just a machine. It is a technological breakthrough that is already helping in dozens of hospitals across the United States, quietly revolutionizing healthcare. Unlike medical robots typically associated with surgeries or diagnostics, Moxy was not designed to replace doctors or nurses, but to assist them. Its main mission is to relieve medical staff of routine, time-consuming tasks so that they can spend more time on what truly matters: patient care. Moxy looks like a friendly semi-humanoid. It stands about 1.2 meters tall, moves on a wheeled base, has one multifunctional robotic arm, and a head with expressive eyes that can smile or nod, creating the effect of lifelike interaction. Its tasks include delivering samples to laboratories, transporting clean linens, medications, medical instruments, and protective equipment. A Gemini-powered robot, facing an entirely unfamiliar object, a toy basketball hoop, took a moment, reasoned through what a slam dunk might mean, and executed the move perfectly. No task-specific training, no human puppeteering behind the curtain, just real-time, on-the-fly understanding and action. That was the moment when everything changed. Carolina Parada, head of robotics at Google DeepMind, summed it up best. She called it a wow moment. And she wasn't exaggerating. We've seen robots dance, climb stairs, and do backflips. But we haven't seen this. A robot using general-purpose intelligence to interpret human language and translate it into coordinated physical action with absolutely zero prep. This wasn't just about a party trick. It was about Gemini, the next-generation AI model that now sits at the heart of Google's vision for robotics. What makes Gemini different is its seamless fusion of language and vision. It doesn't just understand words. It sees, interprets, reasons, and acts. When the robot was told to slam dunk, it didn't panic. It didn't stand still. It analyzed its surroundings, identified the hoop, located the ball, and made a plan. Then it executed. That's not pre-programmed behavior. That's cognitive flexibility. And that's where DeepMind's new learning architecture comes into play. This isn't just another foundation model update. What they're building is an entirely new framework for robotic learning. One where models are not trained for weeks on a single task, but are instead exposed to diverse sensory input and learn through generalization. In front of you is the well-known robot named Grace, designed for healthcare and assisting patients. Hanson Robotics Company has stated that their development could revolutionize the healthcare market. The humanoid robot was created to interact with elderly individuals. Grace is equipped with sensors, including a thermal imaging camera in her chest to measure a patient's temperature and pulse. This allows medical professionals to diagnose patients without direct physical contact. Grace uses artificial intelligence to assess patients and can speak 3 languages: English, Mandarin, and Cantonese, enabling effective communication. The CEO and founder of Hanson Robotics, David Hanson, explains that robots like Grace are designed to support healthcare workers rather than replace them. As mentioned earlier, the robot's primary function is to reduce loneliness and improve the mental well-being of patients by engaging with them and offering mood-boosting activities, such as conversational therapy and guided meditation. Researchers at the University of Sheffield have developed the robotic system Medatel, designed to provide medical assistance to the wounded in combat zones and other hazardous environments. This innovative robot is equipped with 2 manipulators that allow remote measurement of temperature, blood pressure, heart rate, and even abdominal palpation. The system is controlled using virtual reality. Medical specialists can use VR headsets to examine and treat patients from a distance. In emergency situations, Medatel can remotely send photos and videos of injuries to trained medical personnel and conduct observations, such as measuring a patient's temperature and blood pressure. The robot is capable of operating in environments with radioactive contamination, biological threats, and active combat zones. In the near future, robots will be capable of fully replacing medical personnel in performing routine and technically complex tasks. One of the most advanced solutions in this field is Yumi, a mobile and autonomous medical robot capable of working alongside doctors and laboratory workers. Yumi features a dual-arm design with 14 axes of movement, ensuring high maneuverability and precision. This allows it to perform delicate procedures such as liquid dispensing, test tube sorting, and handling laboratory equipment. With its machine vision system, Yumi can recognize objects, analyze their position, and manipulate them carefully without risk of damage. Yumi can be programmed to perform repetitive tasks such as automatically opening test tubes, loading centrifuges, or sorting medical samples, thereby reducing the workload on staff and increasing the speed of analysis processing. Researchers from the American company Gamard Scientific have developed a robot designed to train healthcare professionals using various medical instruments. This robot named Hal resembles a 5-year-old boy and introduces new educational technologies. Hal looks and behaves like a small child. He can follow a finger with his eyes, answer questions, cry, call for his mother, and even experience anaphylactic shock. He can also show fear by breathing faster or wetting himself. He is designed to help doctors and nurses learn to perform specific procedures, such as measuring blood pressure and pulse, or monitoring breathing. Hal can be resuscitated using a defibrillator, and his throat can be cut open to insert a tracheal intubation tube. The boy can even flinch and say ouch when given an injection, mimicking the reactions of a real young patient. When developing Hal, the creators deliberately chose not to include highly realistic features, such as freckles or hair follicles. They feared that if Hal were to die or experience a cardiac arrest, it could cause emotional distress for students practicing on him. The Chinese company Forier Intelligence has created a unique robot named Forier GR1, which can be used as a physiotherapist. However, at the moment, the robot's movements are controlled by an operator since artificial intelligence has not yet been developed for it. In the future, GR1 will be used in medical institutions, for example, to help immobilized patients lie down on a bed or sit in a wheelchair. GR1 can maintain balance while walking and perform various tasks, according to the head of Forier Intelligence Zenko. The robot can be programmed to sit, stand, jump, use tableware, and handle different tools. This will enable GR1 to work as a home assistant, a rehabilitation program aide, or even a companion for a lonely elderly person. American engineers from the company Intuitive Surgical have developed one of the most efficient medical robots named Da Vinci Xi. This high-tech system is designed for performing complex surgical procedures with minimal intervention, providing precision, control, and flexibility that surpass traditional methods. DaVinci is equipped with multiple mechanical manipulators that fully replicate a surgeon's movements, but with greater accuracy and without natural hand tremors. The system enables minimally invasive surgeries through tiny incisions, significantly reducing blood loss, lowering the risk of complications and speeding up patient recovery. Its wristed instruments offer greater mobility than the human hand, while tremor filtration and intuitive movement technologies ensure natural and precise manipulations. The price of this robot is $1,900,000. That wraps up this week's AI robot update, and honestly, every week feels more like science fiction turning into reality. With robots evolving faster than ever, the line between human and machine is starting to blur. We'll be tracking every mind-blowing moment, so make sure you're following along. Trust me, you do not want to miss what's coming next. Thanks for watching, and we'll catch you in the next one.